All right, let's start talking our way through the warm-up. On the first one, number 3, are we looking for a leg or the hypotenuse? Hypotenuse. How do we know that it's the hypotenuse that we're looking for? It's across from the right angle. Across from the right angle is my hypotenuse, which always has to be C in the Pythagorean theorem. Can I use a Pythagorean triple for this one? No, there is no Pythagorean triple that has a 4 and a 7 in it. There's a 3, 4, 5. There's a 7, 24, 25, but there isn't one that has a 4 and a 7 in it. So we're going to use Pythagorean theorem. A squared plus B squared equals C squared. We're going to put the 4 in for either A or B. We're going to put the 7 in for the other one. So I'm going to put 4 in for A and 7 in for B, but the order there does not matter. So I would have 4 squared plus 7 squared equals C squared. 4 squared is 16. 7 squared is 49. What is 16 plus 49? 65. So 65 equals C squared. What do I need to do now? Square root. If you do it to one side, you've got to do it to the other side. On the right, the squared and the square root cancel each other out, which gives me just C on the right-hand side. On the left-hand side, we have the square root of 65, but I need to see if that can simplify at all. So let's try. Because of that last digit, I know what number can go into 65. 5. 65 is 5 times what? 5 times 13. What can go into 5? What did you say? Itself. Itself in 1. 5 is a prime number. What about 13? Same thing, only 13 and 1. This is also a prime number. So I'm not going to be able to find anything times itself under the radical, which means my simplified radical form or reduced radical form is the square root of 65. What would that be in decimal form? 8.1 if we round to just one decimal place. Absolutely correct. And that is what our directions asked us to do. Over here on the directions where it said round to the nearest tenth, that is 1 decimal place. Now, when we do rounding to decimal places, the calculator didn't say 8.1. The calculator said something like 8.062 something, something, something. If we're going to round to a specific decimal place, in this case, we're rounding to the first one. Draw a line in between the first decimal place and the second decimal place. If the number that comes after that cutoff is a 5 or a bigger, then we round the number in front of it up by 1. So that's why it's rounded to 8.1. All right, number 4. Are we looking for the hypotenuse or a leg? Leg. What's the hypotenuse then? 10. Opposite that right angle is my hypotenuse. Can I use a Pythagorean triple on this one? Nope. There's a 3, 4, 5 triangle, but there's not a 3 something 10 triangle. So we have to use Pythagorean theorem here, no shortcuts. A squared plus B squared equals C squared. In the place of C, we have to put the 10. That's the only piece that's picky about where it goes is the hypotenuse. So I have 10 squared over here. On the other side, I have to put the 3 in for either the A or the B. Doesn't matter which one. So I'm going to put it in for A. So that would give me 3 squared plus B squared equals 10 squared. So 9 plus B squared is equal to 100. What do I do now? Subtract 9 from both sides. What is 100 minus 9? 91. So I have B squared is equal to 91. And then what do we do? Square root. If you do it to one side, you have to do it to the other side. On the left, the squared and the square root cancel each other out, leaving me with just B. On the right-hand side, I have the square root of 91, but I need to see if that can simplify. What can go into 91? Well, there is something. What can go into 91? I know it's not 2 because it's not even. Can 3 go into it? 7 can go into it. So 91 is 7 times what? We can use division to figure that out. We can do 91 divided by 7. That'll give me the other number. 13. What can go into 7? Nothing. That's a prime number. What about 13? Same thing. This is also a prime number. So since 91 is the product of 2 prime numbers, I'm not going to be able to simplify it any further. So my reduced radical answer would be the square root of 91. What would that be in its decimal form? 9.5. Again, when you put that one into the calculator, it doesn't come out to be perfectly 9.5. It's 9.539 something, something, something. So we do our cutoff right here because the number that comes after that cutoff point is not a 5 or bigger. We do not round the number in front of it up by 1. All right, now we have one last warm-up problem to do. Says Maria thinks her small desk will hold a monitor that is 10 inches tall by 16 inches wide. So I'm going to draw that real quick. 10 inches tall, 16 inches wide. On an online shopping site, she finds a 22-inch monitor measured diagonally. So measured this way. Will the computer fit on Maria's desk? Well, I don't know. What would the diagonal of the desk have to be if the monitor's going to fit? Bigger or smaller than 22? The desk would have to be smaller than the monitor? The desk is going to have to be bigger than the monitor. So I want to know, is this bigger than 22? Let's use Pythagorean theorem to figure that out. Is that the hypotenuse or a leg? Hypotenuse. It is across from the right angles. We're assuming that her desk is a rectangle. So then across from that right angle is the hypotenuse of C. So 10 and 16 have to go in for A and B. Doesn't matter which is which. So I'm going to put 10 in for A. So I put parentheses around it and square it. Plus I put 16 in for B. Parentheses around it and square it. That equals C squared. 10 squared is 100. What's 16 squared? 256. So 100 plus 256 would give me 356 equals C squared. So is the diagonal 356 inches? What do I need to do? Square root. We're going to go ahead and put this right into decimal form because I want to know whether it's bigger or smaller than 22. What is 356 in its decimal form? It's about 18.9. Again, rounding up there. So the monitor is 22 inches. The desk space is a little bit smaller than 19. Will the monitor fit on the desk? No. The monitor will not fit. The desk can only fit an 18.9 inch diagonal. Monitor. Nice work on the warm-up. Let's go ahead and put that away for right now, and we're going to get out your notes. We're going to be on the exact same page that we were working on yesterday, which is page 3, front side of the second piece of paper. We got through examples A, B, C, and D, and we still have E and F. All right. So just as a reminder, our rules for 45, 45, 90 triangles, we just have one rule here. The hypotenuse is equal to the leg times the square root of 2. So that's what we're going to use to solve these problems. So part E, hypotenuse is equal to the leg times the square root of 2. What did they give us on part E? Hypotenuse or leg? They gave us hypotenuse. It is opposite that right angle. So 5 square root of 10 is the hypotenuse. So I'm going to substitute that in. 5 square root of 10 is equal to L times the square root of 2. I want to get the L all by itself. So what do I need to do to isolate L? We're going to divide. What are we dividing by? Not just 2. Square root of 2. We're going to divide both sides by the square root of 2. On the right, that's going to cancel. On the left, I have 5 square root of 10 divided by square root of 2 equals L. We talked yesterday, I am not allowed to leave a radical in the denominator. Yesterday we had to rationalize to get rid of that, but that's because yesterday my numerator didn't also have a radical in it. Today, my numerator has a radical in it. It has square root of 10. So I can handle this one a little bit differently in a slightly easier way. We're going to pull the whole number 5 off to the side. And we're going to make a fraction with the 2 radicals, square root of 10, square root of 2. Those are being multiplied together. When I have a radical, and I have pieces multiplied underneath that radical, I can split it apart and I can give each of those pieces their own radicals. So if I see multiple radicals being multiplied together, I can put them back together underneath one radical. The same thing is true with division. If I have a fraction underneath a division sign, I can break it into 2 radicals, top and bottom. If I have radicals top and bottom in a fraction, I can put them back together underneath one single radical. So I've got a really tall fraction here, or sorry, a really tall radical with the 10 and the 2 underneath it. And now I can simplify that. What is 10 divided by 2? 5. So 5 square root of 5 is the length of each of the legs in this isosceles right triangle. So these 2 legs right here. Five square root of 5. Let's go look at part F, because part F is very, very similar to part E. I know hypotenuse is equal to leg times the square root of 2. My 2 legs are the same size because it's a 45, 45, 90 triangle. This 3 square root of 6 that they gave me, leg or hypotenuse? Hypotenuse, opposite that right angle, so it's the hypotenuse. We're going to go ahead and substitute that in the place of h. 3 square root of 6 is equal to L times the square root of 2. How do I get rid of this square root of 2 over here? We're going to divide by the square root of 2 on each side. Cancels out on the right. On the left, I have 3 square root of 6 over the square root of 2 equals L. I'm not going to go through writing down each individual step here, but I know when I have a radical top and bottom, I can turn that into one single radical with the fraction underneath it. So I would have 6 over 2 with the 3, the whole number on the outside. And then I divide the 6 and the 2. What is 6 divided by 2? 3. So I end up with 3 square root of 3 for the length of my leg. For the length of both legs, actually. The whole number on the outside And what's underneath the radical will not always be the same number. We saw that on previous examples. These two, E and F, the whole number and what's under the radical ended up being the same just by chance. So that's our 45, 45, 90 triangles. I want to talk about the 30, 60, 90 triangles. So we're going to go back up to the top of the page where we have this other triangle that we didn't look at all, the 30, 60, 90. This is an equilateral triangle. What does it mean for a triangle to be equilateral? It means all the sides are equal. If all the sides are equal, what does that mean about the angles? All the angles are also equal. So we have a 60-degree angle down here, a 60-degree angle at C, and B is also a 60-degree angle. Notice there's that dashed line that goes from B to the opposite side, to side AC, and it intersects right here at D. It's making a right angle, which means that BD is an altitude, but because it's an equilateral triangle, it is also a median, so it's cutting this bottom side into two equal parts, and it's an angle bisector. So that means it is splitting angle B into two equal parts. It's taking that 60 degrees and cutting it in half, so it's 30 degrees up there. I want to come up with the relationships that we have with the 30, 60, 90 triangle in a similar way that we did yesterday with the 45, 45, 90, where we were working with a square. So I want to say that each side of this equilateral triangle is 2x. If each side is 2x, then down here at the bottom, how big is each of these sections? X. So x, because x plus x would give me 2x, which would be that whole side. Right, there's a whole lot going on in this picture. So I'm going to take just half of this equilateral triangle, and I'm going to redraw it off to the side. So let's draw this. I'm going to put it up kind of high. All right, so there's my 30, 60, 90 triangle. 90-degree angle right here, 60 degrees here, 30 degrees up here. So again, I've taken this part right here and redrawn it up here. So how big is this part of my 30, 60, 90 triangle? Well, 2x, because that matches to this part right here. So that side is 2x. How big is the bottom part? X. And we don't know how big this part is. We don't know how big that altitude is. We're going to figure out how big that altitude is, but I want to hold off for just a second because there's a relationship that I see already. Where's the hypotenuse in this picture? 2x is my hypotenuse. The other two sides of the triangle have special names. In my 45, 45, 90 triangle, I had the hypotenuse, and then I had two congruent legs. Here, all three sides are different sizes. I have the hypotenuse, and then this piece down here, the part that's labeled as just x, we call this the short leg. And this piece right here that I don't know, this entire side, we call the long leg. Oh, sorry, dear. Get your notes out, dear. I see a relationship between the short leg and the hypotenuse. The short leg is labeled as x, and the long leg is 2 x's. If this short leg was 1, how big would the hypotenuse be? 2. If I put 1 in the place of x here and 1 in the place of x there, that's 2. What about if the short leg was 4? How big would the hypotenuse be? 8. If the short leg was 15, the hypotenuse would be 30. The hypotenuse is always going to be double the size of that short leg. So let's write that down on this line right here. The hypotenuse is equal to the short leg times 2. I'm going to abbreviate that down to H equals SL times 2. I want to try to find a relationship now for the long leg in this 30, 60, 90 triangle. So we're going to use Pythagorean theorem like we did yesterday to try to find a relationship here. So a squared plus b squared equals c squared. How big is the hypotenuse again? What has to go in for c? 2x. So we're going to put 2x in the place of c. Close my parentheses around it and square it. The short leg is x, so I'm going to put that in for either a or b. I choose a. And we don't know the length of the other side, so I'm going to put a question mark in there. So I end up with x squared plus my question mark squared is equal to, we got to make sure to do this part right. What does it mean to square something? Multiply it by itself. So this is 2x times another 2x here. Well, what is 2 times 2? 4. What's x times x? X squared. So 2x squared is 4x squared. I want to get that question mark all alone, so I'm going to subtract x squared from both sides. When I'm subtracting x squared from both sides, how many x's am I subtracting? Just 1. We're subtracting 1x squared. So I've got 4x squared minus 1x squared, which gives us what? 3x squared. What would I need to do now? We're going to square root both sides. I need to get a pencil out and take notes along with us. Thank you. So we're going to square root both sides. If you do it to one side, you have to do it to the other. On the left, the squared and the square root cancel each other out. And so I have question mark equals the square root of 3x squared. What's going on between the 3 and the x squared? Multiplication is happening in between them. Since they're being multiplied, I can give them each their own radical. So I would have square root of 3 times the square root of x squared. And then Jackson, I think you already answered this one. What happens right here? They cancel out. The squared and the square root cancel. And so I have question mark is equal to the square root of 3 times x. Normally, we write this with the part under the radical coming second. So my question mark then would be equal to x square root of 3. That is the length of my long leg. This piece up here. X square root of 3. So then the relationship between my short leg and my long leg is that the long leg, let's see if I can fit this in here. Long leg is equal to the short leg times the square root of 3. Or LL for long leg equals SL for short leg times the square root of 3. So with the 45, 45, 90 triangles, we had one rule to remember. Because two of my sides were the same, so we just had a rule for the hypotenuse. Hypotenuse equals leg times square root of 2. With 30, 60, 90 triangles, we have two relationships that we have to remember. The hypotenuse is the short leg times 2, and the long leg is the short leg times the square root of 3. We're going to flip your page over to the back side, page 4. We're going to do some practice with 30, 60, 90 triangles. Put that away, please. As soon as Dwayne gets back. All right, so let's look at part A. First thing I'm going to do on my 30, 60, 90 triangles is I'm going to label my sides. I'm going to label the hypotenuse first, and then I'm going to label the short leg and the long leg. On part A, which piece of this triangle is the hypotenuse? H, opposite that right angle. Here's my hypotenuse. So then which leg would be my short leg? 5 is my short leg. Which means S is what? Yep. That is the long leg, LL. So short leg, long leg, hypotenuse. We need to find the length of the hypotenuse and the length of the long leg. We just wrote down a relationship. The hypotenuse is equal to what? What did we write down on the other page? Yep. Short leg times 2. They called the hypotenuse lowercase h, so that's what I'm going to put in for h. Short leg, what are we putting in for short leg? 5 times 2 means the hypotenuse is how big? 10. I'm going to add that to my picture. This side is 10. And then we need to find the length of the long leg. What was that relationship? Long leg equals short leg times what? 3? Square root of 3, thank you. Oops. Long leg equals short leg times the square root of 3. What did they call the long leg on this triangle? S. So S is equal to, what does the right side of the equation look like? Five times the square root of 3. And when I have a whole number multiplied to my radical, we don't normally write the multiplication symbol down in between them. So that means side S, which is the long leg, is equal to 5 square root of 3. I'm going to go and add that to the picture. This side is 5 square root of 3. Let's look at the next example. Let's look at example B. We want to label our sides first. Which piece is the hypotenuse on example B? M. So let's label that. Opposite the right angle is my hypotenuse. Let's label the short leg next. Which one is the short leg? 7 square root of 3. So that's SL, which means P is what? P is the long leg. All right, let's find that hypotenuse first. Hypotenuse is equal to, what's that relationship again? SL times 2. They called the hypotenuse M, so I'm going to put that in the place of the H, is equal to what? 7 square root of 3 times 2. What's happening between the 7 and the square root of 3? Multiplication. When I multiply numbers together, does the order I do that in matter? No. 5 times 2 is the same thing as 2 times 5. So I can rearrange my numbers when I'm just multiplying pieces together. I'm going to go ahead and do that on this one. I'm going to bring this 2 over closer to the 7. 7 times 2 times the square root of 3. I can multiply my two whole numbers together here. What is 7 times 2? 14. So m is 14 times the square root of 3, or 14 square root of 3. Let's add that to our picture. Hypotenuse is 14 square root of 3. Now we need to find the long leg. What's the relationship for long leg again? SL times square root of 3. What did they call the long leg on this triangle? P. So P is equal to what? 7 square root of 3 times the square root of 3. And one more time for my benefit, what's going on between the 7 and the square root of 3 right here? They're being multiplied together, absolutely. So I have 7 times root 3 times root 3. I've got root 3 multiplied by itself twice. What do we call it when I take something and multiply it by itself? Squared. So this would be 7 times the square root of 3 squared. And what happens right there? Cancels. The squared and the square root cancel each other out. So I would have P is equal to 7 times what? 7 times 3, because the square root canceled. And 7 times 3 is 21. Last thing I'm going to do is add that to my picture. This side here is 21. Let's do one last problem for today. Part C. Labeling the triangle comes first. We label the hypotenuse first, the longest side. I can always locate the hypotenuse because it is opposite what? The right angle. So what's the hypotenuse on C? Y. What is the short leg? X. Which means 12 is long leg. All of my relationships on a 30, 60, 90 triangle are relating back to my short leg. I don't know how big that short leg is. So that's the first thing I'm going to have to find. So I'm going to have to use my long leg formula. Long leg is equal to short leg times the square root of 3. And I'm going to have to use that to find the length of the short leg. What goes in for LL? 12. What goes in for SL? X. So I have 12 equals X times the square root of 3. I want to get SL by itself. I want to get X by itself. That means I have to get rid of this radical 3 that's being multiplied to it. What operation will get rid of that for me? What operation will get rid of that square root of 3 for me over there? Division. It's being multiplied, so division is going to get rid of it. Cancels out on the right. On the left, I have 12 over the square root of 3 is equal to X. Do I have a radical in my numerator? No. Put that away, please. Can I leave a radical in my denominator? Nope. We cannot leave a radical on bottom. Does anybody remember what we call it when we get rid of this radical in the denominator? Started with an R. Close. Very close. It's rationalizing. We're going to get rid of the radical in my denominator since I don't have a radical in my numerator to divide it with. We have to rationalize this denominator. So we're going to multiply this fraction by another fraction. And on the top and bottom of this other fraction, we put whatever this radical is down here in my denominator. So I have square root of 3 on the top and the bottom of this fraction. Top multiplies to top, bottom multiplies to bottom. So in my numerator, I would have 12 square root of 3. In the denominator, I have square root of 3 times itself, or square root of 3 squared. What happens when I square the square root of 3? Cancels out, leaving me just what in the denominator? Leaving me just 3. So 12 square root of 3 over 3 equals x. We need to look to see if we can divide those whole numbers. What is 12 divided by 3? 4. So 4 square root of 3 is my short leg, x. We're going to find the long leg and then we're done. Or sorry, not long leg. We had long leg. We're going to find the hypotenuse and then we're done. How do you find the hypotenuse? Short leg times 2. Well, how big was that short leg? 4 square root of 3. Hypotenuse is y. So y equals 4 square root of 3 times 2. What's going on between the 4 and the square root of 3? Multiplication. So I can reorder this. Y equals, I'm going to scoot the 2 over here. So 4 times 2 times the square root of 3. What is 4 times 2? 8. Y equals 8 square root of 3. Write that on my picture, and then I'm done. We're going to do a little bit more practice with 30, 60, 90 triangles tomorrow. You can do just about everything on the homework at this point. Oops. Homework is due on Monday, but you can do almost all the pieces there. I believe you can do everything except for maybe the story problems on the back side. You might want to wait until after we've gone through the lesson tomorrow to do the story problems, but everything else should be things that you can do on that homework.